Imagine a sphere of absolute, light-devouring blackness, so vast it dwarfs Jupiter, silently orbiting a distant sun. When you look at it, you don't see a planet, you see a void. 750 light-years from Earth, in the constellation Draco, this void is very real. It is called TRES, 2b. When the Kepler Space Telescope measured the starlight reflecting off this gas giant in 2011, the resulting data fractured standard astrophysical models. The planet reflects just 0.04% of the light that hits it. Put this into perspective. A standard lump of black coal on Earth reflects roughly 5% of the light it receives. Black acrylic paint reflects even less. TRES, 2b, is significantly darker than both. It is the darkest planetary body ever discovered in our galaxy. The standard blueprint for a gas giant like our own Jupiter, which reflects more than a third of incoming sunlight, relies on the presence of highly reflective ammonia clouds. But TRES, 2b is locked in a punishing orbit just 5 million kilometers from its host star. It is tidally locked, meaning one side permanently faces the sun, baking at temperatures exceeding 1,000 degrees Celsius. Reflective ammonia clouds cannot physically exist in this inferno. Instead, the atmosphere is a toxic haze of vaporized sodium, potassium, and gaseous titanium oxide. Yet, even the combined light-absorbing properties of these heavy elements cannot mathematically account for the absolute, terrifying darkness of this world. It is effectively invisible, betraying its existence only through a faint, deep red thermal glow, like a dying ember in a fire. To even detect it, Kepler had to track more than 50 full orbits just to isolate a microscopic variation in the system's brightness, a shift of merely 6 parts per million. Astronomers are forced to admit a profound blind spot. There is an unidentified chemical compound or an entirely unknown atmospheric mechanism dominating this world. If a planet darker than coal forces us to question atmospheric chemistry, another world entirely shatters our assumptions about meteorology. 64 light-years away in the constellation Vulpecula, the Hubble Space Telescope confirmed the visual color of HD 189733b. From a distance, it is a serene, deep cobalt blue. It looks hauntingly like Earth. It is a lethal optical illusion. Slightly larger than Jupiter, HD 189733b completes a full orbit in just over 2 Earth days. Because it is tidally locked, one hemisphere is scorched by eternal daylight, while the other is trapped in endless night. The physics of fluid dynamics dictate that extreme temperature differentials between a day and night side will generate powerful atmospheric currents as the heat violently tries to equalize. Here, that thermal gradient pushes nature to the extreme. The day side boils at over 1,000 degrees Celsius, driving winds into the night side at speeds reaching 7,000 kilometers per hour. That is nearly 7 times the speed of sound. No hurricane recorded on Earth has ever approached a fraction of this kinetic force. And that serene blue hue? It is not vast, life-giving oceans. The atmosphere is saturated with microscopic silicate particles. In the extreme heat, these silicates condense into liquid glass. The supersonic winds catch these molten glass droplets, whipping them across the planet. Because of the sheer, unfathomable velocity of the atmosphere, the precipitation does not fall downward. It rains horizontally. Anything entering this atmosphere would be instantly shredded by a relentless, supersonic barrage of liquid glass traveling faster than a sniper bullet. But meteorology is one thing. 670 light-years away in the constellation Cygnus, a planet named Kelt, 9b, shatters the definition of chemistry itself. Discovered in 2017, its host star is a massive blue-white giant, burning at 10,000 Kelvin, twice as hot as our Sunday. Kelt, 9b orbits this stellar inferno so closely that a single year lasts just 1.5 Earth days. Spectroscopic measurements by the Max Planck Institute for Astronomy confirm that the day-side temperature of this tidally locked planet reaches an astounding 4,600 Kelvin. To make that figure tangible, this planet is hotter than the surface of most red dwarf stars in our galaxy. The very definition of a planet assumes an environment where matter can form basic molecular bonds. Kelt, 9b, violently erases this distinction. At 4,600 Kelvin, the thermal energy is so intense that molecules cannot physically hold themselves together. On the day side, hydrogen gas is literally ripped apart into naked, individual atoms. The extreme atmospheric winds carry these isolated atoms over to the slightly cooler night side, where the temperature drops just enough for them to frantically recombine into hydrogen molecules. But the supersonic winds inevitably drag them back into the daylight, where they are violently torn apart all over again. This is an endless, planetary-scale cycle of atomic destruction and rebirth, and the planet is not surviving it intact. The extreme ultraviolet radiation is boiling, Kelt 9b alive, stripping away its atmosphere at a staggering rate of 100,000 tons of mass every single second. It is bleeding to death, leaving a massive, glowing, comet-like tail of vaporized iron and titanium in its wake. Yet, bleeding to death is a slow demise compared to what is happening 600 light-years away in the constellation Auriga. The gas giant WASP 12b is not merely enduring its star, it is actively being devoured by it. Astronomers at Princeton University spent a decade tracking the intervals of the planet as it crossed the face of its star. They noticed a disturbing, inescapable trend. The time between transits is shortening. WASP 12b's orbit is actively decaying at a measured rate of 29 milliseconds per year. In orbital mechanics, 29 milliseconds is a ticking clock. It is a death sentence. The planet is spiraling inward. The physical mechanics of this execution are brutal. The gravitational pull between the star and the planet creates extreme tidal forces, causing the stellar material to oscillate and create friction. This friction acts as a gravitational drag, bleeding orbital kinetic energy away from WASP 12b and converting it into heat. With every revolution, the planet loses a fraction of its velocity, dropping lower into the gravity well. The tidal forces are now so overwhelming that WASP 12b is no longer a sphere. Gravity has stretched the entire world into an elongated, egg-like ellipsoid. Its atmosphere has swollen to 3 times the radius of Jupiter, and the stellar gravity is actively tearing the outer layers away, forming a vast disk of superheated gas spiraling directly into the star. Astrophysicists project that in approximately 3 million years, a microscopic fraction of cosmic time WASP 12b will be entirely erased from existence. Farther out, at 640 light-years away in the constellation Pisces, WASP 76b proves that the universe does not need water to create a hydrological cycle. It uses heavy metals. Observations from the Very Large Telescope in Chile confirm that the day side of this tidally locked giant reaches an incinerating 2,400 degrees Celsius. At this precise temperature, the physics of metallurgy warp. Iron, which requires immense industrial blast furnaces to melt on Earth, behaves like water here. On the day side, solid iron vaporizes, converting directly into a gas that rises into the upper atmosphere. Massive thermal winds sweep this metallic gas across the terminator line, the twilight boundary, and carry it into the pitch-black night side. Here, temperatures plunge by nearly 1,000 degrees. As the iron vapor cools in the dark, it undergoes condensation, forming heavy, metallic clouds. And then, it falls. Driven by hurricane-force winds in the pitch black, thousands of tons of molten iron plummet from the sky. It is a fully functioning weather system, built entirely out of liquid metal. While WASP 76b bends the rules of thermodynamics, a gas giant discovered in 2023 looks as though a critical error occurred during the mathematical rendering of the universe. WASP 193b orbits a star, 1,200 light-years from Earth. Transit measurements prove it is physically massive, boasting a diameter 1.5 times larger than Jupiter. Yet, radial velocity data, which measures the gravitational tug the planet exerts on its host star, revealed a mass that defied every known model of planetary formation. The mass of WASP 193b is merely 14% of Jupiter's. When you divide its massive volume by this minuscule mass, the resulting density is approximately 0.059 grams per cubic centimeter. It is lighter than water, lighter than cork, and lighter than aerogel. To put it in terrestrial terms, this colossal planet has the exact physical density of cotton candy. Standard models dictate that a gas giant must possess a solid, dense core to generate enough gravity to pull in and retain its massive gaseous envelope. A planet of this immense width should inherently generate enough self-gravity to crush its own atmosphere into a much denser state. Yet WASP 193b exists in a state of extreme, unexplainable inflation. No current model perfectly predicts how a planet this wide can remain this incredibly light without having its atmosphere violently stripped away by stellar winds. But perhaps the most chilling anomaly in the astronomical record takes us back to the very beginning of exoplanetary science. In 1992, astronomers Alexander Woljan and Dale Frail discovered the first confirmed exoplanets outside our solar system. They did not find them orbiting a warm, welcoming sun. They found them orbiting PSR B1257 plus 12, a pulsar. A pulsar is a rapidly spinning neutron star, the ultra-dense, dead remnant left behind after a massive star explodes in a catastrophic supernova. This specific dead star spins with terrifying velocity, sweeping beams of intense radiation across the cosmos. Surrounding it are three rocky planets, aptly named Draugr, Poltergeist, and Phobiter. The unsettling truth is that these planets should not physically exist. A supernova is one of the most violent events in the universe. Any planetary system orbiting the original star should have been instantly vaporized or violently ejected into deep space. Mainstream astrophysics posits two grim possibilities. Either these are the scorched, dead iron cores of former gas giants whose entire atmospheres were blasted away, or they are zombie worlds, formed entirely out of the radioactive ash and debris left behind after the star died. They exist in an environment fundamentally hostile to matter, continuously bathed in lethal torrents of X-ray and gamma-ray radiation. Any surface is baked by hard radiation. The very first planets humanity ever discovered were born from the mechanics of absolute cosmic destruction. The physical universe contains worlds operating under thermodynamic and gravitational conditions that push established physics to the absolute breaking point. Our own solar system, with its stable, rocky planets and orderly gas giants, is not the baseline for planetary mechanics. It is merely a calm, fleeting anomaly in a galaxy defined by extreme, violent, and highly unstable environments. The distance between what we assume is possible and what physics actually permits in deep space is measurable, and the gap is terrifyingly real.